Welcome students. We are back with another lesson, lesson number 46. Now in this lesson we'll discuss the various method of polarization, and in particular we will discuss about Brewster's law. So up till now we have discussed about polarization. So what happens in polarization? A unpolarized light is incident on a polarizer, which is your polarizing filter. Now this unpolarized light is being converted into a linearly polarized light which passes out of this filter. So you are converting your unpolarized light to a polarized light as shown in this figure. Fine. And this method is known as your polarization. Now there are various methods to produce polarization. One of the method is by reflection. So in this figure, an unpolarized light is incident on a water surface. Now when an unpolarized light falls on this water surface, what happens? The light is reflected. But as you look into this figure, the reflected light is polarized, and the rest, see in this case the vibrations, there are different kinds of vibrations which are going into the river, but what happens, only one particular type of vibration is coming out of the river. So your light is polarized light. For this you can look at this example. Suppose there is a fish inside this water. So when a light is incident on this fish, the light is reflected and it falls on your human eye. Now when it falls on your human eye, you see only the top part, which is shown by this arrow, fine, which is this top part, but we cannot see the sidereal part, this below part. We see only the dorsal part, the upper part of the fish, but the side part, which is shown by this arrow, we cannot see. Why? Because this part of the surface is showing the polarization. Fine, that's why you see the light which is coming out of here, it's polarized. Now what will be, which part will be polarized, which part will be unpolarized, will depend upon the shape of your fish. So light is incident at a particular angle. Now if it is reflected and it falls on our human eye, now if it is incident at a particular angle, this angle will be known as your Brewster's law, which we will discuss in our today's class. Okay, so when the light is incident at a Brewster's law, what happens? The incident light, which is unpolarized light, will be converted into a polarized light, and it will form an image in our human eye. This is what is happening here. The dorsal part, the top part is being polarized, whereas the down part is unpolarized. Fine. So the unpolarized light goes into the water, whereas the polarized part is being reflected, which falls onto our normal human eye. Next is polarization by scattering. So suppose you have a unpolarized light. Okay, this arrow shows in which direction the waves are vibrating. It is vibrating along y-axis, along x-axis, and along xy, and along y-axis. Fine. So this is a unpolarized light which is incident on a particle. Let us consider this to be a particle. It can be this particle, it can be your atom, or it can be molecule. Okay, for now you just consider it like to be a body. Okay, consider it to be a body. So when an unpolarized light is incident on this body, what happens? This body emits radiation. This is the first radiation which is coming out. This is the second radiation which is coming out. This is the third radiation which is coming out. All these radiations are emitted at different angles. Now when you look at this radiation, the one which is coming out here, it is unpolarized. Fine. Whereas this one also, can you see, this is polarized. Can you see this arrow? This arrow shows the vibration in which you have more vibrations. So in this case, this Y has more vibration as compared to the other arrows. That's why you have a bigger arrow. So the light or the wave coming in this direction is partially polarized, whereas the light which is coming out in this angle, okay, can you see the vibration is in one dimension, it is restricted to one plane only. So in this case, the light or the waves which is coming out at this angle is polarized. So you have converted your unpolarized light to your polarized light by the method of scattering. Moving to our next one, which is your absorption. You know The light which is emitted by the sunlight, okay, this is a unpolarized light. It consists of all the wavelengths of the light, which is violet, indigo, blue, green, yellow, orange, red. Okay, so what happens when this unpolarized falls on your normal day-to-day products, like let us say banana in this case? So what happens, this banana reflects only the yellow light, rest all of these lights are being absorbed. So this type of polarization, where you see it has different color wavelengths, fine, different color wavelengths, but the ones which is being produced by this body, which is your banana, is only yellow in color. So you are converting your unpolarized light to your polarized light. So this method is known as absorption, where this banana is absorbing all other wavelengths and producing or emitting only the yellow wavelength, fine. So in this case also, what is happening is that you have a higher intensity of light which is being incident on a material. This material absorbs various waves and emits only a particular linearly polarized light. So in this case, have you seen what happened? The light's intensity has been reduced. Why? Because this light is of a particular wavelength. Fine. The light produced by this material is particular wavelength, just like in this banana. The color coming out is only yellow color. Similarly, the light produced by this is of particular wavelength, which is vibrating in a particular direction. So this method of polarization is known as your absorption. And the final one is your double refraction. Now in this case, what happens, you have a specific kind of materials. Okay, now what happens in such materials is that the light or the unpolarized light, when it falls on such materials, it refracts the light in two cases. Okay, this is your, or it reflects the light into two rays, your ordinary rays and your extraordinary rays. Okay, this depends upon the angle at which it is incidence. For now, you can only understand that this is an unpolarized light which is falls on this material, and you have one ray coming out in this direction which has ordinary ray, and this is the other ray which is coming out in this direction, which is your extraordinary ray. Now in this case, the light is vibrating along perpendicular to this paper. The light is vibrating perpendicular to this paper, and in this extraordinary ray, the light is vibrating along the paper, fine, like this. So what happens is that this material has produced double refraction. Okay, this material has produced double refraction, which you can see in this picture. Suppose there is an image of a dot here. The light which is being produced from somewhere down part here. Okay, can you see there are two rays, two of the lights coming out? There are 2 plus, 2 cross, 2 cross, 2 plus in this case. Why? Because one of the rays is your ordinary rays and the other rays is known as your extraordinary rays. Okay, so the ordinary rays are vibrating in a specific plane, and the extraordinary rays are vibrating in a specific plane, fine. So such kind of material exhibits a particular property, and this property is known as your birefringes. Okay, this double refraction, this birefringes, is something which you will study in your higher classes. For now, we are particularly focused on this one, the polarization by reflection. So it was in the year 1808 when your French physicist Malus, he discovered that when an ordinary light, your unpolarized light, is incident on a surface of a transparent medium, the light reflected back is partially polarized. So in this case, can you see, this is your unpolarized light which is incident on a transparent medium. Now the light which is reflected back is polarized. Can you see the vibrations? They are in a particular plane only. So he noticed that this polarization depends on a particular angle. So what happens at particular angle, what happens, the reflected light, okay, this light is completely polarized. Now the angle of incidence at which the unpolarized light falling on this transparent surface is reflected as a beam of completely polarized light. Okay, now this angle will be known as your Brewster's angle or your polarizing angle. So consider here, this is your transparent medium and you have a incident unpolarized light. Now to show its vibration, okay, now consider this red arrows. Okay, this shows the vibrations and they are vibrating along the plane of the paper. Fine. Now consider this green dots. Okay, let me just zoom in. Fine. Now can you see this green dots? This represents the vibrations which are coming out of this paper. Okay, which is coming out of the screen towards you. Fine. This shows the vibrations which is in your direction. Okay, it is going back and forth, in up and down in your direction, coming out of your screen. Fine. Now when the light is incident at Brewster's angle, which is denoted by I suffix P, what happens? Now what you'll notice is that this light will be reflected as well as this will be refracted. Now the reflected light, okay, this reflected light which will have vibrations in a particular direction will be a polarized light, and the vibrations will be coming towards you. Okay, this vibration, green dots, it will be coming towards you. So your reflected light is a polarized light, whereas this refracted light will be unpolarized light. Fine. So it was your physicist David Brewster who found out this angle IP. That's why this angle is known as your Brewster's angle. And he showed that the relation between the Brewster's angle and the material, how your Brewster's angle is dependent on this material. So let's see how it is dependent. Fine. So look in this figure. So this is your incident ray and this angle is known as your incident angle. This is your reflected ray and this angle is your reflected angle. Now your incident angle and your reflected angle are same. Fine. So instead of giving a separate notation, I will write this reflected angle or also as IP. And this is your refracted light and this is your normal. So this angle is your refracted angle of refraction. And this is represented by RP. Okay, that's why I've not denoted this notation as R, because this R represents your angle of refraction. Okay, in order to avoid the confusion, I will write the reflected ray also, which from the first law we know it will be same as your incident angle. That's why I have written IP here for your reflected angle and RP for your refracted angle. Nice. Fine. Now in this case, this angle, the angle between your reflected light and your refracted light is always 90 degree. Fine. This angle is 90 degree. So consider this line. This is your straight line normal. So what is this total angle? The total angle is 360. So if IP represents the polarizing angle of incidence, which is your Brewster's angle, and RP represents your angle of refraction, then I can write the sum of all this total angle should be how much? 360 degree. Since this is a straight line, sorry, not 360, I mean 180 degree. This is a straight line and this total angle should be 180 degree. Fine. So IP, this IP plus this angle 90 degree plus this angle RP should be how much? It should be 180 degree. Fine. Now this 90 and this 90, I'll send this one. So 180 minus 90 will be 90 degree. Therefore IP plus RP should be equals to 90 degree. So IP plus RP equals to 90 degree, or I can also write my angle RPS. If I send this IP to the other side, then RP equals to 90 minus IP. Fine. So this is the relation between IP and RP. Now we know from Snell's law, your refractive index mu equals to sine IP upon sine of RP. Now let us substitute this value here. Then your refractive index mu can be written as sine of 90 minus IP. And what is sine of 90 minus IP? It is cos of IP. And sine IP by cos IP equals to tan IP. So this is an important relation. Fine. And this relation is known as your Brewster's law. So what does this law states? That the refractive index of any medium is equal to the tangent of its polarizing angle. Fine. This is your Brewster's law. So that's it for today's class. Thank you. And if you have any confusion, please don't hesitate to ask. I will re-explain it to you again. So again, thank you.